Alright, hey everybody, welcome. Today we are starting a new chapter on chapter 10, and the very first thing we're going to be talking about is going to be simplifying square roots. Today's lesson is going to be nice, short, quick, and to the point, along with 10.2 and 10.3. Let's check them out. Again, we're simplifying square roots. Very first thing I want you to do is please write down these words. You need an expression that contains a radical sign, and that's what that square root symbol is. It's known as a radical sign, and when an expression contains a radical sign, that is a radical expression. Go figure. Okay. Some examples of radical expressions. If you look at that, those examples below, you got the square root of 14, the square root of L squared plus W squared, square root of 2GD, so on and so forth. Okay, it doesn't matter if there's a multiplication sign in there, doesn't matter if you're adding or if you're squaring underneath the square root. If it has a square root or a radical sign, that's a radical expression, as long as it doesn't have that equal sign. Then, the expression underneath a radical sign is known as the radicand. Okay, so that's your 18, that's your 2, that's your D, that's your 2GD, that's your L squared plus W squared, that's your 14. All of those are going to be your radicands. Alright? You don't have to write this down. I just want you to be thinking about this, having this in your head as you're going through these square roots and you're going through these radical expressions and the radicands. Okay, an expression containing square roots is in simplest form when, and this is the most key one, is going to be the radicand has no perfect square factors other than 1. So when we get past using just the calculator and breaking it down into radical expressions, you need to know that it's completely simplified if the radicand has no perfect squares. The next one says the radicand has no fractions, and that's not talking about, if you look at this, that radicand doesn't have any fractions. Although it is a fraction, you see underneath the radical symbol that 4 is not inside a fraction. This right here, 4 over D, that would be considered not simplified because this square root symbol is, the 4 over D is completely over that, or inside that square root symbol. Then the last one, there are no square roots in any denominator. So if you look at a simple one like this, the square root of 3 over the square root of 2, this is not simplified because we have our square root symbol in the bottom. Again, I just want you to plant this seed now, make sure, hopefully it refreshes some things from last year. Just have them in mind when we solve. First couple, very, very easy. All you're doing is finding the square root. Round to the nearest tenth. So on your calculator, what I want you to do is find your square root button. You might have to hit that second button in the upper left-hand column. Hit that second and then find your squaring symbol. A lot of times your square root is underneath that. Once you hit those two buttons on your calculator, you're going to type in 28. And when you solve and you round to the nearest tenth, the square root of 28 is approximately 5.3. So this one, you're just using your calculators. You're solving very quickly. Try this next one on 97. I'll give you a few seconds. 1, 2, 3. All right. Here we go. Square root of 97. Again, hitting your second button, the square root symbol, and you'll get 9.8. Rounded, approximately 9.8. These ones very easy, just using your calculator to help you solve. Now, write this down. We're going to be moving into radical terms. If you understand this, or if you remember this from last year, please give these ones a shot right now. Awesome. Okay, simplifying the square root, writing in radical terms. When I write in radical terms, I'm basically factoring. Okay, I'm basically factoring the number underneath that radical symbol. I'm basically factoring that radicand into perfect squares. Okay, so if I take the square root of 20, Okay? I know that if I multiply, what's a perfect square that goes inside 20? You got it, 4. Okay, so I know if I multiply the square root of 4 times the square root of 5, that's going to equal the square root of 20. So if I multiply the square root of 4 times the square root of 5, I get 20. Well, when we solve this, what is the square root of 4? Absolutely, it's 2. So when we simplify it, we're going to get 2, but we still have to multiply times our square root of 5. So it's going to be 2 times the square root of 5, and that gives you your answer. This is in simplest form, and it's also in radical terms. Notice we have our radical above that 5, okay? And that's what it's going to mean. Okay, you're factoring out your number, your radicand, which is the number underneath your radical symbol. Factor that out, okay? And then simplify. Okay, find your perfect squares. Okay, this next one, I want you to give this one a shot. See how you do. All right. So this second one. When I'm looking at the second one, I'm going to multiply these two numbers together. I have the square root of 3 times the square root of 27. When I multiply them together, I get the square root of 81. Well, I hope you know this. The square root of 81, off the top of your head, is what? Absolutely, that is 9. So our answer is going to be 9. Last one in this set, we have our square root of 11 times the square root of 6. Again, we're simplifying our square root, so the very first thing we should do is multiply them together. So we have the square root of 66 because we took 11 times 6. Still both of them underneath the square root because neither one of those are perfect squares. But now we have the square root of 66. Inside your head, I want you to be thinking, all right, what are some numbers that I can plug in that would be a perfect square that I could simplify the square root of 66? 4. Nuh-uh. Doesn't work. 4 doesn't go into 66. 9? Doesn't work. Doesn't go into 66. 16? Nope. Okay, how about 25? Absolutely not. So at that point, when I start crawling up those square root numbers, I know if there isn't a square root that goes into it, this is already in simplest form. All I did was multiply them together, and my simplest form is going to be the square root of 66. All right? So factor out your square roots. Get your perfect squares. Once you find your perfect squares, like here on 4 and like here on 81, you solve. Okay, if they are not perfect squares, so if you look at square root of 5, it still stays under that square root of 5. We cannot multiply an integer times a number underneath the square root. That's a rule. We can't do it. Okay, because we don't know exactly what that square root of 5 is. We just know once we have it, we need to multiply it by 2 to get the square root of 20. All right? Next one, find the length of the hypotenuse. Write your answer in radical form. So if I'm looking at this, okay, I'm going to slide this over. Again, we already know how to solve for a right triangle. How do you solve? What theorem or what formula do you know? Think in your head. Hit yourself, and I'm tapping myself in the side of my head right now, thinking, all right, what do I got to do to figure out that hypotenuse? Well, if you remember, it's called the Pythagorean theorem. Pythagorean theorem, when you solve, is a squared plus b squared equals c squared. So, plugging in your a, plugging in your b equals to your c. So, the square root of 13, we got to square that, plus 6 squared is equal to c squared. Well, anytime, remember when if we undo a square root symbol, we are squaring it. So if I took the square root of 13 times the square root of 13, well, that's going to give you an overall answer of 13. 6 times 6 is 36, and we have the c squared still, so we have 49 is equal to c squared. How do you undo the square symbol? You find the square root, yep. So what does c have to be? C has to be 7, okay? And I want to go quickly, just go back up here. If I gave you the square root of 13 times the square root of 13, Well, that right there gives you your answer of 269. Square root of 169. We know on your calculator, if you took the square root of 169, that's how I came up with this. Find the square root of that, you would get an answer of 13, and that's how I came up with this 13 right there. Alright, so last one. This is the last note of the day. It says a softball diamond is a square with the sides of 60 feet. How long is a throw from third base to first base in the softball? Okay, so again, what theorem are we going to use? We have a triangle, and we know that if it is a square, this is going to be a right triangle. So what we're trying to figure out is what is that length from third to first. Alright, how long is that throw going to be? Well, if we have one side, we can figure out that third side. So, again, using Pythagorean theorem of a squared plus b squared equals c squared. Okay, plugging in what you know 60 plus 60 is equal to c squared. And when we get this, we get 3600 plus 3600 is equal to c squared. We need to square root everything. So we know that if we have the square root of 7,200 is equal to c. Now, the very first thing is we want to give it as a radical expression. I can guarantee right now that the square root of 720 is that's not in simplest form. So again, we go to our tree and we can break it down. So we have the square root of 720. Sorry, 7,200. Then we're going to break it down. If I look at this, I know if I multiply, okay, the square root of 900 times 8, the square root of 8, I can get my answer. Okay? Now, as I'm going through this, the square root of 900. What's the square root of 900? Type that on your calculator. You will know that that is a perfect square of 30. However, the square root of 8 can be broken down one more time into another perfect square. What is that perfect square going to be? You got it. It's going to be the square root of 4 and times the square root of 2. So we're still multiplying all of these together. Alright, so now we still have our 30 as our integer. We're still multiplying. What is the square root of 4? You got it. It is 2, and we're still multiplying by our square root of 2. So as a radical expression, we can combine these two integers, okay? Because there's no square root symbol, which means we can combine them. So we have a 60 times the square root of 2. Now that gives us a radical expression. That's in simplest form. Square root of 2 can't be broken down. Now, how did I know 7,000 or 900 went into 7,200? Well, I see that 72 and I know 9 can go in there, and I just added my 2 zeros. Then I have 60 times the square root of 2. When I simplify this out, that's about, alright, again, it's going to be about, rounded to the nearest tenth of a foot, it's going to be about 84.9. What is my, what is my unit that I have used? It's right up there, feet. We're not talking about area or volume anymore. And even though we did square it at the beginning, we took the square root of it, which means that's just your overall answer of 84.9 feet. Alright, that's all I have for today. Remember, simplify your square roots. Make sure that your simplified square roots in a radicand or radical expression is in simplest form. It doesn't have any more perfect squares. There is no fractions, and there's no square roots in your denominator. If you know that and you simplify it all as much as possible, you guys will be fine. Awesome. I'll see you later.